So, where do these comets come from? These objects, actually, we still believe, are left over from the formation of our solar system, but they're probably not where they were originally. And we believe that basically they've been sort of kicked into different areas, probably from interaction with the Jovian planets, Jupiter being probably the likeliest suspect, again because of its huge size and its very strong gravitational influence. We basically find that comets seem to be originating in two different areas. The first is the Kuiper belt, which is basically out beyond the orbit of Neptune and more or less lies within the plane of our solar system, maybe tilted a little bit. But these comets are going to be orbiting in the same direction and more or less be sort of part of the whole solar system. The comets that might originate in the Kuiper belt would be comets that we would consider short period comets, and what that means is that their orbital periods around the Sun would be something less than 200 years. Now, an object in the Kuiper belt isn't necessarily a comet. It's really basically, it might become a comet if it gets kicked into an orbit that pulls it in to an orbit that gets it very close to the Sun. So out here in both of these areas, we sort of have a lot of comet potentials in the Kuiper belt. And then surrounding in all directions our solar system is another area, and it's much further away, about 50,000 astronomical units, is what we call the Oort cloud. And these are objects that got kicked way out into space in all different directions and are sort of randomly moving around the Sun, but they don't have any preferential motion. There's not a certain rotation or revolution. And this is the area where we would find a long period comet. The one picture that I showed you of a comet that was observed in the late 90s was the Hale-Bopp, which when studied was found to have an orbital period of about 2,500 years. This is where Hale-Bopp would have originated in the Oort cloud. So this is where we would find long period comets. These comets will tend to have orbits that come at the Sun from all different directions, where the short period comets will probably be orbiting in the same direction as the rest of the planets. So here's a picture of Kuiper belt objects, and essentially it's kind of exciting as time has gone on, as I've been teaching. We've gone from the point where Kuiper belt objects were hypothesized to where we were actually able to detect them mainly with the Hubble telescope. And we have found several objects that are part of the Kuiper belt objects. And we have even been able to find objects out in the Oort cloud as well. Something that you might not be aware of is that meteor showers are actually connected to comets. Think about what's happening as a comet is orbiting around the Sun. It's successfully sort of releasing material from the nucleus, and this material can become accumulated along the orbit. It will continue moving in the orbit, but it won't be part of the comet anymore. And so remember that meteor showers are things that are predictable. So you might be familiar with, in August, the Perseid meteor showers occurs, or in November we have the Leonids. People always know when the meteor showers are going to occur, and the reason is what's happening is the Earth's orbit is passing through the debris of a comet. And when we're passing through the debris, of course, this debris can enter our atmosphere and produce a lot of meteors in the sky. We know when this is going to happen because we know the orbit of the comet and we know the orbit of the Earth, and we know when they're going to intersect. And this is what makes comets predictable. You probably know, I mean, I just listed a couple different meteor showers like the Leonids and the Perseids. The name of the shower comes from the point from which the meteors appear to originate. It comes from the name of the constellation where they appear to radiate from, and this point is referred to as the radiant. It's sort of similar to how, as we're driving through a snowstorm, the snowflakes seem to be coming at us but sort of radiating from a single point. As we're moving through the debris of a comet, the same thing's happening. All the debris appears to be coming from a single point, and that's where we get the name from for the meteor shower. And here's just a nice picture from your book of a meteor shower taking place. Here's a table from the book, which is kind of nice to show you the different meteor showers that are visible during the year. The best time to see a meteor shower is probably around 3 or 4 in the morning. It's best after midnight, and of course, obviously, it has to be at night. A famous impact of a comet I just like to talk about is the Shoemaker-Levy 9 comet, which was actually a comet that got pulled into an unstable orbit around Jupiter, and then Jupiter's gravitational pull actually broke it apart into many pieces. And as astronomers were studying this, it became clear that these pieces, because they came into an unstable orbit around Jupiter, were going to eventually hit the planet. It was just it was a great timing, because the Galileo spacecraft was out there taking pictures of Jupiter, and they were able to get pictures of both the comet after it broke apart and also as it hit. And here you see sort of the pictures that Galileo took as the pieces of that comet hit. And also here we see pictures of sort of what the atmosphere remained looking like a little bit after the comet hit. So we're going to finish up today's talk thinking about poor little Pluto. I hope you do watch that video on the Pluto files. It's a very good video, and it does a good job of explaining why Pluto has been demoted from the status of from a planet, and it also sort of explains to you and shows you that not everyone's on the same page with this. So is Pluto a planet? Well, sadly, it no longer is. The people who decided that Pluto would no longer be a planet, this was a decision that was made at a meeting of the International Astronomical Union, and a lot of people in the room, they basically came up with a definition of what a planet would be, and it was fashioned in a way that Pluto would not satisfy the conditions for being a planet, and instead became what we call a dwarf planet. The definition that they came up with, Pluto satisfies in some respects. It does have enough self-gravity to be spherical, and it is in an orbit around the sun, but it does not clear out the area around it, because it actually, we have found, while at first we thought that Pluto had one major moon, there's a couple other moons, and there's other debris in the orbit of Pluto thanks to the Kuiper belt. So you can sort of think about, and I've asked you to write about, whether you're comfortable with this decision. And there was a little bit of controversy. Part of the reason is because the definition was really fashioned so that Pluto would not be a planet. And part of the reason was that we were starting to find and identifying a lot of objects in the Kuiper belt which were significantly larger than Pluto. And we knew as time went on there would be sort of the issue, do we include all these objects as part of our solar system and call them planets as well, or do we sort of draw a line in the sand? Another part of the controversy was that when the vote was held, an overwhelming amount of the people in the International Astronomical Union who voted were actually not planetary scientists, but were just astronomers. So it was viewed that it wasn't sort of part of their expertise. So here we see some of the issues with Pluto. Pluto does have a very eccentric orbit. One of the interesting things about its orbit is that it actually brings it in closer to the Sun than Neptune for about 20 years of its 248-year orbit, which is kind of interesting. It's also tilted a rather large amount from the ecliptic plane that the rest of our solar system lies in. Another reason that it sort of didn't fit in. It has, its main moon is called Charon, which is very similar in size to Pluto. It's not that much smaller than it. And they have an interesting gravitational interaction with each other in that they always, the same side of the planet and Charon are always facing each other, and that means that they're both rotating and revolving at the same rate. And also notice how Pluto is another planet that's tilted and basically rotating on its side, similar to how we see Uranus rotating. And as time went on, scientists found two other moons for Pluto, Hydra and Nix, which, again, because they're pretty similar in size to Pluto, goes towards the argument that maybe it should just be called a dwarf planet. And here we see, notice how Pluto's orbit does go within the Kuiper belt. And it's basically, it was just big enough to be discovered. But there are other objects out there that we are starting to find that also are just as significant in size as Pluto, if not sometimes they're actually bigger. So here we see just a couple dwarf planets listed. There's Ceres, which is actually in the asteroid belt, and we're finding more dwarf planets all the time. So again, as I said, it also probably was more of a practical point as well. We're going to find more and more of these objects, and will we include all of them as being official planets, or should we come up with this other category? And that's the way astronomers went, is this new category of the dwarf planets. Here's another orbit of one of the dwarf planets that's been found. It's also known as Xena or Eris. And so that finishes up. Next time we're going to look at how we can find other planets orbiting other stars.